Today we're going to further explore the concept of solving a system of equations by elimination. Now, there's a couple different ways to solve a system of equation, and we've got substitution, we've got graphing, but elimination is a great method. Makes the problem go a little bit quicker on problems in which we don't have a variable solved for. So when you don't see y or x by itself, this is a great method. And so the whole idea is to change one of the equations so that we can add the two equations together, canceling out one of the unknowns. So you got to think about which variable do you want to cancel. And so in this case, we could multiply this bottom equation by 3 or multiply the bottom equation by -2. Either way, it will either cancel out the y's or the x's. And so we'll go ahead and do that. I'll go ahead and multiply this bottom one by 3. That way I don't have to change the signs of any of the terms. And so I go ahead and rewrite my first equation as 3x plus 2y equals 6. Bottom equation is now -3x plus 3y, and now equals -6. So when I add these equations together, I get those x's to end up canceling. So what I'm left with is just a 5y equals 0. And a lot of people aren't too sure about what to do from this point because we have it equaling 0. Sometimes people think it's a no solution, but it's not. It is actually y is 0. So when you go ahead and divide by 5 on both sides, you end up with 5 going into 0, 0 times. Just think about it this way. 5 times what number equals 0? Well, the only number 5 times any number, or actually any value times by this number of 0 always equals 0. So y is 0. Well, just take that 0 and substitute back into one of the equations. I think it'd be easier to put it in for this bottom equation that we modified, but you can use the original equation there, -x, and then plus the 0 equals -2. So 0 plus -x is still just -x, so we have the opposite of x is -2. So all you have to do is divide by or multiply by a negative, and that will cancel out the negative sign in front of the x term, leaving us just with the x equals 2. So there it is. 2 comma 0 is the solution. So what the solution is an ordered pair where these two lines end up crossing. So let's take a look at the next one here. Here we have a situation in which we can't just multiply one of the equations. We need to multiply both. And so I'm going to go ahead and cancel out my x terms, because when I multiply to cancel out the x terms, I have to multiply by smaller numbers. If I try to multiply by the y terms, they're bigger values. So I'm going to multiply this top equation by 3. Every number up top gets multiplied by 3. So it's now 6x plus 15y equals, and then multiply that out, you get 6 and 3 make 18, carry a 1, 3 and 2 make 6, plus 1 makes 7. So this one, bottom one, is going to end up needing a 2, because the signs are already opposite, just needs to multiply by 2, and it makes it -6x, and that's what we get for that first one here. So 2 times the -3 makes the -6x, 2 times the -4y makes a -8y, and multiplying that, we get -50. So we can go ahead and add these two numbers together. We get a 7y equals, and then this makes a 28 when I multiply those numbers together. And always just check your signs, make sure they're right. You see we have more positives than negatives, so it does end up making sense. So divide by that 7, we get y as 4. Substitute this 4 back in, and whichever one seems easier. It looks like I'm going to try this one right up here. And so I have 2x plus 5 times by 4 equals 26. So when I do that math, I get 20, and then I just need to take that 20 from 26. So I'll subtract that from both sides, and that leaves me with this 2x equals 6. So I go ahead and do that division here, and I have this divide by 2 on both sides. I get x as 3. So there it is, 3 comma 4 is the point where the two lines cross. So this next one, same sort of thing. I've got opposite signs here. I could multiply by a smaller number if I use this one. Or I could just multiply by 1. That's a little bit bigger, but the signs are already the opposite. So I'm going to try that. I'm going to just multiply this one by 2, every number there by 2, and that gives me a -10x plus 4y equals 64. And then when I go ahead and multiply this one, I'm just multiplying by 5, and then I end up with a 10x and a plus 15y, and this all equals 50. So when I add these numbers together, this time I get those x's to cancel out. So I end up with a 19y equals, now this is 50, so this makes 104, actually 114. So 114. So let's see if 9 ends up going into this number. And again, just to kind of double check your numbers here at this stage. Sometimes it's easier to do that. Here we have 64. Yeah, that makes sense. 50, that's right. That does make that number. And we have 2 and 2 makes 4. 3 and 5 make 15. So it's always good to check your numbers, especially when you think it might not go in there. But then from here, as I think about numbers that multiply from 19 to make 114, I'm thinking of 9 times an even number. So like 9 times by 6 makes 54. So I might try that. 19 times by 6. And so I end up with a 54, and that carry a 5, that makes 11. So it does end up working out. So 6 was the right number there. So from this point, we're going to take that 6 and substitute it back into one of these equations. So pick the easier one. I'm going to pick this one right here, this bottom one. So 2x plus 3 times by 6 equals 10. And so I go ahead and do some work there. And always thinking about my signs really carefully. Here I have 18 equals 10. And I do some subtraction, and I end up subtracting 18 from 10, so I end up with a negative. So this is why I have to think about my signs here. 2x equals negative 8, divide by 2. Okay, I should be getting a negative number there because I just have the one negative, negative 4, and there's my answer. So always when you're doing these problems, think about those signs, think about opposite operations, make sure you're doing the right work as you go. Otherwise, you might know what you're doing, but you might end up making a small little math error and getting the wrong answer. Well, here's some other word problems, and you'll see at least one of these on your homework tonight, where we have Lee spent $31 on movie tickets, the Lees did, and they bought 2 adult tickets and 3 children's tickets. The Maces spent $26 on the same movie for tickets for just 2 adults and 2 children. They want to find out the cost of an adult ticket, which we'll call A, cost of children's ticket, which we'll call C. So let's take a look at the Lees equation. It's just 2 adults, so 2A, plus 3 children, 3C, equals $31. Now the Maces, well, the Maces have a different equation. They still have the same number of adults, 2A, but they only have 2 children, so 2C, and that's why it costs less money, $26. So now we've got our 2 equations. Now we can go ahead and solve. So the way we're going to solve this one is just multiply one of the equations by a negative. Now careful on the one you pick. I'm going to pick this bottom one, the Maces equation. And the reason I'm going to do that is because this way I won't have to deal with the negative numbers once I subtract. So let's go ahead and rewrite the Lees. 2A plus 3C equals 31. And the Maces is now negative 2A minus 2C equals negative 26. You see, when I add these 2 equations together, I'm going to end up getting the A's to cancel, but here I end up with just C, and that's going to give me my answer directly. Here I subtract, and I end up with 5. So $5 for a children's ticket. That's one of the answers. The other one is just to substitute. Take that 5 and substitute into one of these C values here. I'm going to take the Maces equation again. 2A plus 2 times by 5 equals 26. So when you multiply the 2 and the 5, you get 10. So now we got 2A plus 10 equals 26. All you have to do is subtract out that 10 from the 26. And that will give you the cost of 2 adult tickets, which is $16. Dividing by 2 gives you the cost of just 1 adult ticket, $8. So there it is. Look at the last one here. It talks about how Ed spent $57 on allergy shots, on 4 allergy shots for one office visit. So that's a value equation. We just don't know the cost of these allergy shots, and that's what they're going to ask for. How much does an office visit cost, and how much does an allergy shot cost? So let's try writing that first equation. It's a value equation, so we have 4A, because 4 times the cost of an allergy shot, and 1 office visit, so we're going to go with V for an office visit, so it doesn't look like an O. And so we have 4A plus 1V equals 57. Reading the next equation, it says this month he spent only $9 on everything. So he spent $9 on one office visit and a refund of 2 allergy shots. So you got to be careful here. So he went to the office. So he had that office visit. $9 was the cost here. Now the allergy shots, though, was a refund. Refund means we're taking away. And so we're taking away 2 allergy shots, the cost of those 2 allergy shots. But we did visit the office, so we have a plus 1V. So what we can do is do the same thing we did on the last problem. We can end up multiplying by a negative, and let's do that. Multiply by -1 here, and it'll cancel out our V terms. So let's rewrite what we've got. 4A plus 1V equals 57. And this other one's going to be 2A minus V. Now it's positive 2A because the negative signs cancel, equals -9. When I add these together, I end up with 6A equals, now I got to subtract here, so this gives me 48. And so from that point, all I have to do is divide by 6. Because 6 allergy shots cost $48, so divide by 6, it gives me the cost of 1, which is $8. And then from there, I can go ahead and figure out how much a visit costs, an office visit. And so I'll just substitute, and I'll put it in for this V right here. So I have 4 times by 8, and then plus V, or 1V, equals 57. So this makes 32 plus V equals 57. And then I can just subtract that 32 from both sides. And so when I do that, I end up with V equals, and this makes $25. So $25 for the office visit, but an allergy shot only costs $8. So there are our answers. So those are the types of problems you'll end up seeing on tonight's homework. Good luck.
Oh.